everyone, my name is Pavitra V, Department of Chemistry. Today we are going to discuss a topic called thermodynamics. Thermodynamics is actually a branch of science which deals with the relationships between heat, work, and energy. Actually, it also involves the study of behavior of energy and its interaction with the matter of various scales or sizes, from the smallest molecules to the largest scale molecules or the systems. Next, we will discuss first law of thermodynamics. The first law states that energy can neither be created nor be destroyed, but it can be converted from one form to another form. So, this is the first law of thermodynamics, and we have a mathematical equation for this, that is delta E is equal to Q minus W, where delta is E is the change in energy. Delta refers change, small change in energy of the system. Q is the heat added to the system and W is the work done by the system. So this is the equation of first law of thermodynamics. Next we will discuss second law of thermodynamics. Second law of thermodynamics deals with the entropy, that is entropy of an isolated system always increases over time. That is entropy is nothing but randomness of the system which is increasing continuously in the universe. Mathematical equation is given by delta S is equal to delta Q divided by T, where delta is the change in entropy, delta Q is the heat transferred, and T is the temperature at which the heat is transferred. So this is second law of thermodynamics. Next we will discuss the process in thermodynamics, that is two types, spontaneous process and non-spontaneous process. Spontaneous process is nothing but which takes place by itself without any external aid or external help. That process is called spontaneous process. For example, melting of ice, water flowing downhill, that is upper level to lower level. These are spontaneous process which do not require any help. Next is non-spontaneous process. They are the process which do not take place by itself. It requires an external aid or help to process. These processes tend to move towards a state of higher energy or the lower entropy. Entropy is nothing but randomness. For example, water flowing uphill, that is lower level to higher level. The ball rolling up a hill. So these are the non-spontaneous process. Next we will discuss the entropy. The definition of entropy already we have discussed. This is the measure of disorderness or randomness or uncertainty in the system. So it can be thought of as a measure of amount of thermal energy unavailable to do work in the system. So the entropy is measured in joules per Kelvin. This is the unit and it is denoted by capital S. Significance of entropy. Why we need this entropy means to measure the disorderness of the system and the direction of spontaneous process. As we have told, the spontaneous process in which randomness increases. So we can come to know that whether the process is spontaneous or non-spontaneous. Next, the third one is energy availability. As we know that entropy is a measure of energy unavailability to do the work in the system. So higher the entropy means lesser will be the energy for available to do work. Next is thermodynamic efficiency. So entropy is used to calculate the thermodynamic efficiency such as in heat engines and refrigerators. For example, Carnot engine and all. Next is statistical interpretation. So entropy can also be used for this by relating to the number of possible microstates in a system. So these are the significance of entropy. Next we will discuss entropy and the spontaneity relationship. You can see this, delta S is greater than 0, then the process is said to be spontaneous in nature. Delta is nothing but randomness. Randomness is increasing in a process, then it is spontaneous. If entropy, change in entropy is less than 0, that is negative, then it is non-spontaneous. If delta S is 0, there is no change in the entropy, then the process is at equilibrium. There is no change in the system. So this is the entropy and the spontaneity relationship. Next we will discuss free energy. Free energy is nothing but the energy available to do the work in the system. There are two types of free energies. One is Helmholtz free energy and another one is Gibbs free energy. Helmholtz free energy is denoted by capital A. The equation is A is equal to U minus Ts, where A is the Helmholtz free energy, U is internal energy, T is the temperature and S is the entropy. Here when we comes to the Gibbs free energy, capital G, the mathematical equation is G is equal to H minus Ts, where G is Gibbs free energy, H is enthalpy, T is temperature and S is entropy.